Okay, we're into section 1.5, and what I'm going to do in this section, I'm going to explain to you the counterexample method. And what the counterexample method is, it's a method you could use to determine and demonstrate that a deductive argument is invalid. Okay, you can prove the invalidity of a deductive argument using this method, the counterexample method. That will demonstrate invalidity. Okay, you can't use this test to determine validity. I already gave you that test in a previous discussion, which was if you could falsify the conclusion. Meaning you falsify the conclusion, and if there is a contradiction, you know that the deductive argument is valid. So that previous discussion was a test for validity. This is a test for invalidity. It's called the counterexample method, and I think you're going to like it. It's going to take me a little bit to explain to you how this works, but I think you'll find it kind of interesting, and I'll give you a few examples. Okay, so let's just jump right into the handout here. Proving deductive invalidity, not validity, the counterexample method. Use this method if you know or suspect that an argument has an invalid form. Now there's some good news here. The exercises you're going to get in the book where they want you to use the counterexample method, they all are going to be invalid. Okay, so you're at least given that, which means you'll be able to come up with a counterexample if you work at it. You'll be able to come up with one. That'll make more sense a little later on, but there is good news that the arguments you'll be giving, they're invalid, so they just want you to get used to using this method and come up with a counterexample method, which you'll be able to do. Okay, so what is this method? It's got two steps. First of all, you have an argument that you suspect is invalid, but remember the exercises, the argument will be invalid. You are first to isolate the argument form, and I'm going to explain what I mean by argument form. You probably already know if you've been watching the previous lectures and reading the book. So you isolate the argument form of an argument that you suspect is invalid and get the argument form out. Then you construct a substitution instance having true premises and a false conclusion. Now here, you remember previously I've been talking about being a Martian. Pretend you're a Martian, you don't know anything about Earth, and assume that the premises are true. For this counterexample method, let's leave the Martian mode. You don't have to assume the premises are true, or we're not going to use that phrase, given the premises. I want you to come up with premises that you know are either true or false according to reality. You're not a Martian anymore, you're an Earthling. Once again, you're a human being, and we're just going to pick premises that you know are really true, and you're going to deal with premises. The reason you know they're false is because you know that they don't refer to reality, or they're opposed to reality. So let's leave Martian mode for the counterexample method. Okay? So you're going to isolate the argument form, then you're going to construct a substitution instance having true premises and a false conclusion. And I'm going to explain what a substitution instance is in a minute here. If you can do this, once you isolate an argument form, like if you had an argument and the argument form was if P then Q, Q therefore P. Okay, there would be an argument form, and I'll explain more about that down here. And then you construct a substitution instance, and really what that is you replace these symbols referring to the propositions of the original argument that you think is invalid, and you substitute them with different propositions. That would be a substitution instance of the argument form that you got out of the original argument that you're trying to determine its validity or not. Okay? Now if you can construct a substitution instance that gives you true premises and a false conclusion, then the argument is invalid, because you have showed that the structure or form of the argument in question can deliver a false conclusion from true premises, something that a valid argument will never do. If you have an argument with really true premises, now we're going to leave Martian mode, it's just true premises, and it's structured properly, it's valid. So you have a valid skeleton, the bones are all lined up, a valid argument with really true premises that will never ever deliver a false conclusion, false to reality conclusion. So if you can take an argument form from an original argument that you wonder is invalid, you take out the skeleton, you put in different sentences, a substitution instance with true premises, and that delivers a really false conclusion, then you know you don't have a valid argument, okay? Because a valid argument with really true premises will never give you a false conclusion. So if you can construct and put back into that original form a substitution instance with true premises and a false conclusion, you know that the argument is invalid. And I didn't bring up table 1.1 before, but if you go to section 1.4 and look at table 1.1, if you look under the column for valid argument forms, okay, you got valid and invalid on that table. The only square that you have no example is if you have a valid argument form, a valid skeleton, there's no example of true premises delivering a false conclusion. I suppose I could show it to you here in the book. It's in section 1.4. Here it is. I'll kind of have you see that. But yeah, it doesn't look like you're going to be able to see that. But under the valid column, if you came down, let me raise that, there, right here, you're going to have it empty. Okay, under the valid column, the row with true premises and false conclusion, it's empty. There is no example. You can't have a valid argument, good structure, good skeleton, the bones lined up with really true premises, ever giving you a false conclusion. Okay? You'll only find that in the invalid column. Okay, now if that confuses you, don't worry. And don't worry, I'm going to explain this. So the counterexample method is you're looking at an original argument. You want to see if it's invalid. Pull out the argument form, just like when I did up here, right? Put in a substitution instance. See if you can put one in there that'll work with true premises and a false conclusion. If you can, the original argument is invalid. If you can't, well, let's not go if you can't, but if you can, put a substitution instance in there with you know, the argument form with true premises, false conclusion, it is invalid. Okay, now don't worry. I know, you know, here you have 2 steps and I gave you so much detail you're probably lost already. Let's go through this a little more sequentially and slowly. First, let me make sure you understand what an argument form is, because the first step is you have to isolate an argument form. So let's come down here. You probably already know what an argument form is, the bare bones skeleton or the structure or form or arrangement. So here, we've done it before. If it's raining outside, the streets will be wet. It's raining outside, therefore the streets are wet. I've done that, but for now, I want you to use P and Q because we want to just get out the generic form. So let's even get it away from raining and wet, streets wet. Let's get it away from R's and W's. That's why I'm telling you to use the P's and Q's. So if we were going to do that, let's go back, erase those. If it's raining outside, P, then the streets are wet, Q. It's raining outside, then the streets are wet. P's and Q's in logical forms is like the X in algebra. You know, if you've taken algebra, X can equal just whatever. So that's what we're doing here with the P's and Q's. Let's just isolate the form, and it's this. If P, then Q, P, therefore Q. That is the argument form. This is the argument form of this argument. Okay, let's do another one. And we'll use G, M, and B here. All G are M, all M RB, all G, RB. So this would be all G, RM, all M, RB, sorry for the little sloppy writing there, and all G, RB. That's the argument form, and then let's just make it more generic. We could go all P, RQ, all Q, R, and then we could have all P, RR. You know, if we wanted to just make this just a little bit more generic, we're just interested in what is the argument form. We really want to even divorce it, get it away from geese and migratory waterfall or raining or streets will be wet. That's why let's go to P's and Q's. And even though I did the G, M, and B for bird, waterfowl, migratory waterfowl, and geese, I then went again to make it more generic. Okay, that's what I mean by argument forms. Here's an argument, get the argument form, bam, it's right there. Here's another argument, pull out the skeleton, bam, it's right there. Okay, so that's what we mean by argument form, and you have an argument, you want to isolate it, you know what that means. Okay, let's focus on substitution instance a little bit more. That's step 2 of the counterexample method, right? Construct a substitution instance, but we're looking for a particular kind. One that is true premises, true to real life. Remember, leaving Martian mode. Don't worry about Martian mode on the counterexample method. And we want to have a false premise, you know, as long as we're consistent with the terms that we're given. So now, let's focus on what a substitution instance is. So we've got an argument form, and here we have one up here. Let's pull that one down. If P, then Q, P, therefore Q. Okay, so we brought this down here. Okay, and a substitution instance of this argument form is any argument that is produced by uniformly substituting or consistently. Whatever P is here, it's got to be here. Whatever Q is there, Q's got to be there. That's what it means by uniformly or consistently substituting terms or statements, new propositions. So instead of it's raining outside for P, we're going to use Abraham Lincoln died at the theater. Instead of the streets will be wet, we're going to, for Q, Abraham Lincoln was assassinated. So when you have an argument that is produced by uniformly substituting terms or statements in place of letters in an argument form. Here's our argument form. Now we're going to construct a substitution instance. So P is Abraham Lincoln died at the theater. So if we have if Abraham Lincoln died at the theater, then he was assassinated. Okay, let's just kind of quarantine that off. Okay, and then Q is he was assassinated. Then he was assassinated. So here's your P, there's your Q. Then the second premise is P. Abraham Lincoln died at the theater. Therefore, let's extend the page. Q, he was assassinated. Let's see. Okay, let me just get my spelling right here. Erase that right there. Okay, come back. He was assassinated. Okay, this whole thing is a substitution instance of this argument form. Okay, there it is right there. That's what we mean by a substitution instance. Okay, it's any argument, here's a new argument, that is produced by uniformly substituting terms or statements in place of the letters. Here's the letters. We've substituted or replaced them with new terms or statements. This becomes an argument, and it's consistent. If Q is Abraham Lincoln died at the theater, then anywhere Q shows up, you better have that, right? I mean P. So P, he died at the theater. The second premise, he died at the theater. Q, if Q is he was assassinated, then Q down here, he was assassinated, okay? So you have the two things. You isolate the argument form, construct a substitution instance. I then slowed down. Here's what I mean by an argument form. You probably already knew that. Here's what I mean by a substitution instance. Now that we understand argument form, substitution instance, let's go to that test, okay? So here we have something that we suspect is invalid, and I can spill the beans. It is invalid. Let's use the counterexample method. Now, whatever argument, they already have given us the argument form. So step one, isolate the argument form. It's already been done for us. So there it is right there. Now what we're trying to do is let's find a substitution instance for this argument form, which was a skeleton pulled out of a previous argument, okay? And let's and see if we can put statements in there that are true, the premises are true, and uniformly and consistently keeping the A's, the C's, the C's, we come up with a false conclusion. If we can do that, we can demonstrate that the form is invalid. Such a substitution would provide a concrete example of a case where the A's are in B's, and here the C's are in B's, but the A's are not in the C's, okay? So we have three terms here. Now here's the thing. Let's go down here. Why is the counterexample method helpful? Let's say you have an argument that you're not sure with the terms given. The point of the substitution instance, you isolate the form, then you construct a substitution instance, is if you readily can't determine if an argument has an invalid form, if you isolate the said argument form and use a substitution instance, now I'm going to underline some terms, with more familiar terms that have true premises and a false conclusion, it helps you see that the argument is invalid. So you'll see what I mean by that. But the substitution instance, you might be going, why can't you just look at the original one, Dave, and see if it's invalid? Sometimes it's hard. But if you replace those propositions originally used with easier terms like anteaters, ants, cats, or mammals, animals, or fish, birds, reptiles, uniformly incorporating them, and then sometimes you can go, those are true premises, but all cats are reptiles. That's false. It's easier to start seeing that you have true premises and a false conclusion. Okay? So the substitution instance, the new one you come up with new, easier terms, is what really helps. Okay, so here's our, let's go back now. Here's our argument form. And we're going to use a substitution instance. See, you're going to have to do the work of experimenting, trying this, trying that. I've given you one here. So let's say you have an argument before you came up with the all A or B, all C or B, all A or C. We've got this from an original argument. You're looking at the original argument, you kind of scratch your head and go, I don't know. Well, I'll use the counterexample method. I've got my form. It is isolated. And then I'm gonna slap. It's like you have meat and bones together. That's the argument. You take the bones, the skeleton, away from the meat. So you have right here a skeleton, and you're putting new meat back on the skeleton, but it's meat that's just easier to read, okay? So let's just do this here with A is anteaters, B is animals, C is cats. So if we put that in, we have all anteaters. All anteaters are, and B is animals. Okay, is that true? That's true. Okay. And then the next one is all cats. Right? C is cats, so we're going to go all cats are animals. Is that true? All cats are animals. That is true. Remember, we're trying to come up with a substitution instance of this, that we can put on this argument form where the premises are true, and we're trying to see if it'll deliver a false conclusion, because if it can, we know it's not valid, because a valid skeleton will never, with true premises, ever deliver a false conclusion. Go look at table 1.1 again. Under the valid column, the one box that's completely empty is true premises and a false conclusion. You only see that in the invalid. So if we come up with true premises with a false conclusion, we know it's invalid. Okay? And then the conclusion is all anteaters. Let's go back here. We're doing the substitute. We're constructing the substitution instance right now. All anteaters are cats. All right. Are all anteaters are cats? True or false? That is false. So look what we have. With this isolated argument form, we could slap onto it a new substitution. It's a new meat. All anteaters with true premises, but they deliver a false conclusion. So we know that this argument, the argument, there was an argument. Original argument was here. Okay? And it delivered this isolated argument form, and we know that we were able to put on a substitution instance, true premises, giving us a real false conclusion. Therefore, we know it's invalid, because if we had had a valid skeleton, a good skeleton, you would never get true premises and being uniform and consistent ever giving you a conclusion that was false to the reality that we have here, right? So we know it's invalid. Okay, this is what the counterexample method is all about. I'm going to read this again. I read it before. It is very helpful when you can't readily determine if an argument has invalid form. But by isolating the said argument form up here where my pen's going wacko, and using a substitution instance with more familiar terms, anteaters, cats, animals, if you kind of use genus and class and species, stuff like that, subclass, class, things like that, they really help. With more familiar terms that have true premises and a false conclusion, you can prove that the argument is invalid. And I have a tip here, and then I'm going to give you examples on the next video. A tip on coming up with the right substitution instance using more familiar terms. You're going to have to experiment. What if you use candles, green, plastic? You try that and that doesn't work. Anteaters, animals, and cats, I gave that to you. You're going to have to figure out and come up with something, okay? You may try that, that won't work, but here's a tip. You're going to have to come up with 3 terms, right? Or whatever the terms are. It may not be 3, it could be 2, I suppose. Because the Abraham Lincoln one, there was a substitution instance with just 2 terms. He died at the theater and he was assassinated. Go ahead and start with the conclusion and purposely make it false. Let's say you were trying different things and you go, okay, I'll use anteaters and cats. All anteaters are cats. That's false. So if A is anteaters, I'm going to put the anteater up here, cats there, and see if you can work it out that they're true. So the tip is to find that substitution instance. Begin with the conclusion and use terms that make the conclusion intentionally false, and then uniformly consistently distribute remaining terms in the premises that make the premises true. Okay? And with that, we'll stop, and then the next video on the counterexample method, I'll just go over 3 examples so you get how this works. Okay?